Dear learners, in this video we will speak about the stress-strain relationship for a ductile material. So this is the stress-strain relationship diagram for a ductile material. A mild steel or a low carbon steel is taken, and this is the tensile test specimen of the material, and this is the length of the specimen, and this is the part where it is fixed in the fixture in a tensile test machine. And if the tensile machine produces tensile forces and it pulls the material, over pulling the material, a neck will be forming in the material. When this is explained by a graph, and in this graph, the strain is taken in the x-axis and the stress is taken in the y-axis. And if the element is loaded, the stress is directly proportional to the strain, and there is one limit called as elastic limit. Within this elastic limit, the it makes a slope. Why? Because the stress is directly proportional to the strain, and it is explained in the Hooke's law that the if a material is loaded within elastic limits, the stress is proportional to the strain and it will be equal to a constant that is called as Young's modulus or modulus of elasticity. And and the material is further loaded, it reaches the B point where it loses its elastic limit. If the elastic limit is if the elastic limit is low, then it goes to a region called as plastic region. The difference between elastic region and plastic region is if a material is loaded within elastic limit and the load is removed, and the material is capable of regaining its original shape within this elastic limit, and that region is called as elastic region. And the material is loaded up beyond the elastic region, I mean the beyond the elastic limit, it goes to the plastic region where the material permanently deforms, and even after the load is removed, the material will not regain its original shape. So that region is called as plastic region. At B point, every material will have one elastic limit, and that is specified with this B point, that is elastic limit. If the material, if the load on the material is removed within these points, then the material will regain its original shape. And if it reaches beyond this elastic limit, then it falls to the plastic region. At point C, there is a stress called as yield stress occurs, where where the strength becomes reducing. These are two yield points. One is called as upper yield point, and another one is called as lower yield point. This is the region where yield will be very high, and beyond this loading, it reaches to a maximum limit, and that is called as ultimate tensile stress. This is the maximum allowable stress for a material, and the forming works and every other works will be done within this uh, allowable stress region. After reaching the ultimate tensile stress, if the material is further loaded, then the curve falls down and the material breaks. And F is the breaking point, and it is the failure of the material. So for safe working, the material should be worked within this allowable stress. This is the stress strain curve for a ductile material. I hope everyone understood the concept of stress strain for a ductile material. Thanks for watching the video.